Hey guys, today we're going to talk about interference paints. What are they? How do they work? What makes them different from other paint pigments? Most importantly, how can you mix them to get the greatest effect? Well, I hope to cover all of that and more in the simplest terms possible. I could find surprisingly little on the subject of mixing regular pigments with light effects pigments and powders. Everything that I'm bringing you today is based on my understanding of light and color. Again, I am by no means an expert. So, if I get something wrong, I would love to hear from you guys about correcting it. With that being said, let's dive in. In the color and light video of this series, I touched on what mica and effects pigments are. To recap, mica, interference, chameleon, and other effects powders are small particles of transparent material that are coated with varying thicknesses of a highly refractive oxide layer. The type and thickness of the oxide determines the color that will reflect back to your eye. Effects pigments work much in the same way as structural coloration does in nature. So instead of looking at effects pigments as colors, you should look at them as little lights encased in a medium. I went and bought all the interference colors I could find at my local art store. I'm going to show you the interference colors by themselves and also how they interact with different acrylic colors. I managed to get a hold of interference red, green, blue, violet, and orange. I tested those with singular pigment paints in Hansa Yellow Light, Quinacridone Red, Phthalo Blue red shade, and Dioxazine Purple red shade. First, let's look at a light mixing wheel again. As you can see, the primary colors of light are red, blue, and green. If you combine these three colors of light in equal amounts, the results will be white light. We also have secondary colors on this wheel. Red and green combine to make yellow, green and blue make cyan, then blue and red combine to make magenta. We can see this in action when we look at interference paints. Here I have interference red, blue, and green. Notice how vibrant it is against the black paint versus the white paper. Interference pigments will also be affected by the background color that you use. A light background, such as white, will reflect more light back through the pigment and can change the color you see. The color that is reflected back will be the complement of the original interference. A dark background, such as black, will eliminate the extra reflection, leaving you only to see the main color of the interference. When we combine the primary colors, we create interference colors in the secondary range. Here you can see I've created interference colors in yellow, cyan, and magenta. At the very end, I have mixed all three primaries to create a white interference. So, in theory, you can create many different interference colors with just red, blue, and green by varying the amount of each color used. If I were to make a mix of red and green, I could add twice as much red than green and end up most likely getting an orangey red color than the more yellow gold you get when mixing them evenly. Right away you can see the difference between the black and white backgrounds. The dark background allows the true interference color to reflect back. The black paint is absorbing all the light that reaches it, so it can't reflect anything back into the interference mica. With the white background, you have the opposite. All the light is being reflected back through the interference's mica platelets. This causes a color shift into the complementary color of the original light. So, even though these are continuous swipes of paint, the amount of light interacting with each space differs, yielding different colors within the same paint. Interference colors are somewhat difficult to film and photograph. They change given the angle viewed and the light shining on them. These photos are edited, but the colors you see are the best representation I can bring you. I took photos and video in several different situations to bring you as many angles as possible. Now that we have seen how interference paints act on their own, let's look at how they interact when mixed with different pigments. I mixed each interference color with Hansa Yellow Light, Quinacridone Red, Phthalo Blue red shade, and Dioxazine Purple, also in red shade. All of these are transparent paints. They will allow the most light through to interact with the interference micas. They are still pigments and therefore absorbing light to show the color that they are. This will affect the way each interference color is shown or not within the mixture. Let's check out the interference blue mixes first. The paint color is going to absorb its complementary color of light. So in the case of blue interference, the Hansa Yellow is going to be the one that blocks the effects the most. The interference is trying to only shine back blue light. The yellow paint is absorbing everything except yellow light, which, if you remember, is a combination of red and green. As a result, you will still get a reflection, but it will be white light reflected back due to the mixing of all the colors. Check out the red. You can see the blue interference reflected back against the black background. Against the white, it seems more of a pink color. Mixing blue light with red light will produce magenta. With our blue paint, adding the blue interference increases the amount of blue light that's being reflected, resulting in a more vibrant color. The dioxazine is going to be reflecting back red and blue light, so adding in the blue interference increases the blue reflected back. You will also notice that in some lights, the complement of the blue interference appears to be an orange color. Moving on to the interference green. Starting with the Quinacridone Red, we can see that the interference ends up showing back yellow against the black background. We have red light being reflected along with green light. Red and green create yellow. The yellow paint is reflecting back red and green light, so adding in the interference increases the green light reflecting back. With the Phthalo Blue paint, we have blue light reflected. Adding in the green creates a cyan color reflected back against the black. In the purple paint, the green is still reflected back, just not as brightly as other combinations. Most is canceled out because magenta and green are complements. Now let's look at the interference red. The Hansa Yellow paint is reflecting back red and green light. Adding in the interference enhances the red that shows up. With the red, again, adding the same color paint and interference will produce a more vivid version of that color. The blue paint shows a magenta color against the black. With the purple, we are again increasing the amount of red light reflected back. Moving on to the orange interference. Orange light is going to be a variation of yellow light, so red and green combined. The red paint seems to get a real kick with the orange interference. With the yellow paint, we are increasing the amount of yellow and green light reflected. This ends up giving a gold-like shimmer. The blue light from the phthalo paint is a complement to the orange light from the interference. It ends up mostly canceling each other out. Again, with the purple, the red light is increased, showing a more red reflection against the black background. Last but not least, interference violet. Violet is a color on the light spectrum. The problem here is that the cones in our eyes only see the primary colors of light. It is the combination of those colors that let us see all the other colors on the spectrum. Like the purple paint, we are seeing some combination of red and blue light being reflected back. So in the red paint, we increase the amount of red light, but the blue light forming the purple doesn't go away. The reflection ends up being a purple color. In the yellow, we are combining red and green with red and blue. We increase the red, green and blue form cyan. Again, we have red and blue colored lights, so we get a purple color reflected back. Both the blue and purple paints have an increase in blue light, so the intensity is increased. Whew! We made it through them all. I just threw a ton of information at you, and it can be a lot to digest. At the end of this video, I'm going to lay out these combinations and give you some information that will help you when you get started mixing. Having some of these rules written down somewhere will make it easier to know what you are doing when mixing colors I haven't covered here. To conclude this color mixing lesson, I want to remind you that it isn't 100% necessary to know every single color combination in existence. Sometimes half the fun of making custom mixed paint colors is the surprise of what you end up with. This guide was meant to be a basic introduction to combining additive and subtractive light theories. I find the process to be fascinating. Being able to see the science behind art is eye-opening. I hope that I was able to bring you some new and illuminating information to put into practice. If you have any questions about anything I covered in this video, please feel free to reach out. I'm still relatively new to all this information as well, but together I'm sure we can come up with most of the answers. Also, if you have anything specific that you would like for me to cover, whether it's something to do with mixing paints and micas, or if it's on a completely different subject, let me know below. In the next video, I will talk about all the knowledge we've learned so far and how we can use it to our advantage when creating acrylic pours. That's going to be it from me. I'm going to leave you with some information screens. Here I will give you a list of primary, secondary, and complementary colors of light and break down the things I described with the pigment mixtures earlier. I'm also including a list of pigment colors and the color light they absorb. They are basic pure pigments, but you can use that as a base to guesstimate on other colors. Alright guys, I'll see you next time. Bye!